Today we're going to talk about multiplicative relationships. Previous lesson was over additive. So let's do a do now about it. Write equations determine the total amount A, Alexis earns, given the amount E she earns by babysitting. So the total amount she earned by babysitting is 1, and total amount earned is 6. 2, 7, 3, and 8. So the relationship rule is plus 5, plus 5, plus 5. So you're adding 5 to the total amount earned by babysitting, which is the letter E. So E plus 5 equal A. If you turn it around, A equal E plus 5. So the total amount she earned is 5 more than amount earned by babysitting. So let's talk about our first. Andrea wants to buy a dress for a party. She plans to save $5 each week. Complete the table below for the amount of money that Andrea has in her saving account. So if she works 0 weeks, she'll make $0. 1 week, $5. 2 is 10. 3 is 15. 4 is 20. How did I know that? I multiply by 5. So write an expression for the amount of money in Andrea's account each week. So I'm multiplying 5 by the number of weeks. So it's W times 5, or 5 times the number of weeks, or 5W. Use the expression that you wrote in part 2 to determine how much money that Andrea will have after 15 weeks. 5 times the number of weeks of 15 is $75. That's a lot of money. Write an equation that shows the relationship between the number of weeks and things. So you're multiplying 5 by the number of weeks, it equals the amount of money earned, M. So M equal 5W, or you can do W times 5 equal M. All of these mean the same thing. So the money she makes is equal to 5 times the number of $5 per week. If Andrea had $35, use your expression to write an equation that models this situation that solves the equation. Explain it. So she has $35. So that's how much money she made. 5 times the number of weeks. So how many weeks would that be? 5 times, W will equal 7. So it's 7 weeks. Graph the information. So if she makes $0, she works 0 weeks, she makes $0. 1 week is $5. 2 weeks is $10. 3 weeks is $15. 4 weeks is $20. So I connect the dot, it makes a line. So it goes up $5 per week. If Andrea had saved $30, write an equation that models the situation. How can you use the graph to predict? Well, let's think. If 0, 1, 0, 0, 1, and then 0, 0, 1, 5, 2, 10, 3, 15, 4, 20, so I know it's going to be up here, so it'll be something 30. 5, 25, 6. 6 weeks. Another way to do it is, the equation is M equal 5 times the number of weeks. We know she made $30. 5 times what? W, the number of weeks, equals 30. 6 weeks. Explain any connection. All of these mean the exact same thing. They all represent the exact same thing about Andrea making $5 per week. Let's use a different pen color, red. Andrea's brother Daniel wants to buy a shirt for the party. Daniel plans to save $10 more than a number of weeks. Complete the table. So $10 more than a week. So $10 more than 10. $10 more than a number of weeks. So 11, 12, 13, 14. So graph the information in your table. So in 0 week, he saves $10. 1 week, he saves 11. 2 weeks, saves 12. 3 weeks, 13. 4 weeks, 14. So this line, on the other hand, goes like this way. Write an equation that shows the relationship between the number of weeks thing. So we're adding 10 to the number of weeks, so you're adding 10 to the number of weeks, and it equals the money he makes, or M equals W plus 10. Which person has an additive? Well, the only one that we added was this one. So Daniel has the additive. Which one has a multiplicative? Andrea, because her was multiplied by 5. So let's answer 2 word problems about this. Melinda pays $375 in car payment each month. Which table best represents the relationship between M, the number of months, and C, the amount she pays? So let's see. In the first month, month 1, she'll make $375. In month 2, $375 plus $375 will be $750. Well, C is not correct. Wait, months. Numbers are flip-flop around. Oh, let's do month 3. In month 3, add another 375 is 5, 12. That's 1125. Well, not this one. In month 4 will be 1,500. D is the only one that makes sense. In 4 months, she will have paid $1,500. And last but not least, the table below shows the relationship between the number of cafeteria tables and number of seats for students. Which equation will be used to determine S, the number of seats for students, in terms of N? Let's see, it's times 12. 3 times 12 is 36, 5 times 12 is 60, 7 times 12. So it's times 12. You're multiplying the N by 12. Well, this is dividing, this is adding. Well, it's 24. B is the only one that makes sense. This is multiplicative relationship.